Hi. This project is created for Kinetic L-Series MC Design Challenge. The project name is Intelligent Railway Signaling and Train Detection System. Project code is FSL168. This project mainly aims to increase the safety of unmanned railway crossings in India. There is an estimated 750 casual and non-casual accidents taking place at unmanned railway crossing in India according to Indian Railway Service. This project mainly uses RF transmitter to transmit data from the place where train is detected to the unmanned level crossing. This is the RF transmitter circuit and this is the receiver circuit. Now let us see in detail the transmitter circuit. The transmitter circuit consists of an L-series microcontroller. The train is detected by an piezoelectric device which is connected to the external interrupt of the microcontroller. The piezoelectric is calibrated to the weight of the train so that it provides a trigger to the microcontroller upon a train arrival. The piezoelectric is placed directly or slightly below the track so that the entire weight of the train is transferred to the piezoelectric. To avoid unnecessary triggers, an high level interrupt is used instead of an edge trigger interrupt to the microcontroller. So upon a train, an external interrupt is given to the microcontroller. The microcontroller then processes the external input interrupt and sends a data through UART to the RF transmitter module. The RF transmitter module used here is an amplitude key shifting RF transmitter which operates at 433 MHz. This is the antenna. The data from the UART is directly given to the data input of the RF transmitter and the data is transmitted to the receiver circuit. The piezoelectric here used to detect the train can also be used to power the entire device, but instead of a single device, an array of piezoelectric can be used to give the necessary power to the microcontroller and a battery bank. The RF transmitter transmits the data from the UART which operates at a baud rate of 300 Hz. The device uses low baud rate to reduce transmission failures. Also, the data is transmitted continuously 3 times to avoid any runtime transmission failure. This is a receiver circuit. The receiver is an RF receiver which operates at 433 MHz. This is the antenna which detects the RF signals. For 433 MHz, the minimum length of an antenna should be at least 10 to 12 centimeter. This RF transmitter is very prone to noise, so the output from the RF transmitter is passed through an comparator or an ADC circuit and then given to the UART input of the microcontroller here. The microcontroller detects the data from the UART and the corresponding functionality takes place. Here the functionality is to turn the green light to blue light. Here blue light is used for clarity in the video. Instead of blue light, a flashing red LED light can also be used. And it also simultaneously triggers the voice IC. Here the voice chip is an IST1820 low cost low power voice chip which is capable of recording 10 seconds of voice. Here a pre-recorded voice is stored so that it will be played back upon a train detection. The amplifier here used is a normal household computer speaker. The entire setup can be powered by solar or a battery bank with other non-conventional energy sources. Because it is difficult to find a power source in a place like an unmanned level crossing. So let us see the functionality of the project. The train here is detected by the piezoelectric. The trigger given to the piezoelectric is here in this project. For example, I am just gonna hit with my finger so that it acts as a train detection. Upon detecting the train, a predefined voice is played in the receiver end for a predefined number of times, and the microcontroller automatically goes to the idle process and waits for the next consecutive trigger. So here I am simulating the train.
Incoming train. Incoming train. Incoming train. Incoming train.
Here you can see
Incoming
the
train.
predefined message of incoming train
Incoming train.
is played again and again for a predefined number of times.
Incoming train. Incoming train.
After a predefined number of times, the microcontroller actually goes to normal state and wait for the next consecutive trigger. So when another train comes, the same, if I hit it again, it will go and play the same thing.
Incoming train. Incoming train. Incoming train. Incoming train. Incoming train. Incoming train.
This project mainly helps to reduce
Incoming train.
the number of casualties and an unmanned level crossing. This also can be used at the
Incoming train.
end of a tunnel, where
Incoming
the other
train.
tunnel, the other entrance, if a train comes,
Incoming train.
a voice, a predefined voice can be played at the
Incoming train.
other end of the tunnel. Thank you.
Incoming train.